Assalamu alaikum, this is Kinan Fadi, and this is my presentation for my PSM1 idea, which is InfraPilot. So InfraPilot idea you can get it from the title itself, which is design and implementation for an intelligent Linux infrastructure monitoring system for real-time resource utilization and proactive issue detection. So this presentation includes several parts here. Let's start with the first one. So nowadays, Linux servers power critical infrastructure for small and medium enterprises worldwide. So these companies use multiple distribution of Linux like Ubuntu, Red Hat, Amazon also distributions, and so on. But here in our project, we are going to focus on the Red Hat distribution because it was designed in the first place to satisfy the company's needs. So in Similar's technology enterprise, which is the stakeholder for my project, so we have discussed some pain point that system administrators come through. Like they can't manage their system in 24 hours a day because they have to sleep, go out, or etc. And also for the lack of that, they can't use the commands that show you the system health for like the HTTP, HTOP, I mean, and top and if that and all of that commands. So due to this limitation, many companies get a problem in their servers and they know it after like an hours, after like 3 or 4 hours. So because of that IT failure, many companies are losing money. And there's a study that showed that organizations lose $400 billion annually due to the unplanned IT failures. Okay, for the problem background. So there is three core problems here. The lack of continuous server visibility, as we said, the reactive rather than productive detection, and no historical data for capacity planning, which mean that when we find a problem, we are not rely on evidence, we are relying on our senses. We are trying to see where is the problem, what happened, and all of that. But in my project, we are going to set a very good view for the system administrators to see where the problem comes from. Okay. So to develop InfraPilot, which is a lightweight Python-based agent that enables continuous monitoring of resource usage on Linux servers running on AWS EC2 instance. Also, it will show a real-time monitoring with rule-based threshold detection, a historical trending analysis for server resources usage over time, like disks, RAMs, and all of that, a centralized visualization through a Grafana dashboard that we are integrated with the agent. He will send a data to that Grafana dashboard, all accomplished via a single interface utilizing fast API hosted on a secure server. It will enable also a design for specifically, it's designed specifically for small and medium enterprises, enterprise cloud deployments. So this is the project thing. For the project objectives here, okay. For objective one, it will examine a current methodology for monitoring Linux resources, including a demand-based agent, which will work in the background of the system. Also, for the time series data storage and rule-based threshold detection. For objective two here, we can see it will construct an InfraPilot demand agent using a Python to continuously collect the CPU, RAM, disk, network, and process matrices. So it will evaluate each matrix against their hosts and generate an alert based on that matrices. For objective three, we will create a centralized backend for time series data storage, implement fast API, REST API, and Grafana dashboard for real-time and historical visualization for the system administrators. For the project scope, like I said, we are targeting now the Red Hat Enterprises Linux. Okay, so the Windows servers and macOS are excluded from the scope. We also have a monitoring scope. The system resources matrices include a CPU utilization, RAM usage, disk utilization, network IO, and all of that. Also, we see like log files correlation for on kill and IO errors, which is included in the matrices that we will collect. For the deployment scope, deployed within a central AWS cloud environment with two EC2 instances running Rachel 9 on hosting the demand agent and hosting the fast API backend. Okay, for the project importance. Okay, for the practical contribution, it will provide direct cost and risk mitigation from unplanned downtime that can come from the IT failures. Also transform servers monitoring from manual reactive process into an automated reactive discipline. So, which is rely on evidence, as I said. For the technical contribution, uh, it will have a clear gap in current. We will have a clear gap in current Linux monitoring tools. So no single tool currently meets the combined need for the STE administrators. That's what we are now trying to do in InfraPilot, rather than the other tools. So for the academic contribution, to demonstrate a successful implementation of a demand-based monitoring using an open source stack, provides reference architecture for agent-based infrastructure monitoring in a cloud environment. For the existing systems here, we have Nagios, one of the oldest open source monitoring solution, uses agent active check the architecture with an RPE, no built-in trend analysis that we are now covering here in the InfraPilot, and doesn't satisfy the STE or SME needs. For the Zabbix here, it's an enterprise level also open source system built-in web interface and historical data storage. But it's a complex. It have a complex installation and maintenance. So for the Datadog also, it's a SaaS service solution with machine learning anomaly detection. Its cost from 23 to 40 per host per month. So if you have multiple hosts for a medium company, it will cost you like $1,000 or more than $1,000 that annual bill you have to pay a month. And we have Ansible. We know Ansible that it's a configuration management tool, not a monitoring solution. But we will have use the playbook of the Ansible to use the monitoring of the matrices and to manage the rule-based matrices that the agent will go through and work based on it. For the technology stack, we are using Python and Python libraries, PSUTL, rule-based detection engine, as I said, fast API, and Grafana dashboard, which showing the analysis of the matrices. We also use a timescale database to store the matrices, and we are using a 256 encryption methodology. We are using also an Ansible playbooks to deploy the machine to deploy from the developer machine to EC2 instances. For the methodology choices here. So for the technical uncertainties at project institution required prototyping, so the exact JSON payload structure and time scale database query formats could not be finalized without testing. Also for the emphasis of reusing existing software components, like we're using, as we said, a built-in libraries for Python. We're using Grafana dashboards. We are using timescale and fast API. For the phases approach, the phases approach provides a clear structure with deadline aligning with PSM1 and PSM2 to continue for its requirements. So development laptop, that's what we are needing, with 4 GB of RAM and 46 GB of SSD, which SSD is not, it's not a big consideration that we are going to consider. An EC2 instances in AWS, a backend server, also it's going to be an EC2 instance, an AWS VPC network that allow traffic goes inbound for the EC2 instances. Like we are going to use the HTTPS, HTTP, and so on. But we are focusing on HTTPS because we want it to be secure. For the software we're using PSUTL, Fast API, and all software that we have mentioned earlier. For the system architecture also, we have a monitored server tiers. So InfraPilot agent runs as a supervisor managed demand on Rachel 9. It collects CPU, RAM, disk, network, and process matrices every 30 seconds using PSUTL, which this ensures that the system is up to date every 30 seconds, which helps the administrators. So for the backend server tier, also Fast API backend receive process matrices alert play loud. It will validate the agent sended matrices via an API keys to store the data in the timescale database, and it will read the matrices, and based on the matrices it will generate the alerts event. So this is for the system architecture. So this is the use case diagram. So it's simple. It will We will only have the InfraPilot agent and the system administrator that will view the Grafana dashboard later. Here we have a use cases also, from collect the system matrices to view real-time dashboard to configure monitoring rules to take the threshold breach transmit alerts, authenticate agent request, and we have also view historical matrices trend. We have an install agent in a new server. For the functional requirements, we have metric collection, we have a process monitoring, we have threshold detection, an alert transmission, a data storage, a dashboard visualization, and authentication, and log correlation. For the non-functional requirements, we have a performance and reliability, security, scalability, usability, and maintainability. That will ensure that our project is going to satisfy. For the rapid application development phases, we have phase one, which is the initial investigation. So we analyze the Samir technology enterprise monitoring challenges and reviews 5 existing tools that they have used, and we identify the 3 core problems we had discussed in the problem background. For the requirement analysis also, we have defined 8 functional and 6 non-functional requirements. Okay, for the system design, we created a 2-tier architecture, time scale database schema, a REST API endpoint, and Grafana dashboard layout. For the development and testing, we have built Python. For the development and testing, is going to be built with a Python agent based in Python. Using the PSUTL library, we will use also a Fast API backend, timescale database storage, and Grafana dashboard performed until the integration is tested. For the implementation and evaluation, so it will deploy on 2 AWS instances, EC2 instances. The instances will use the Rachel 9 distribution. Okay, so we have achieved a 100% prediction accuracy, 2 CPU, small like 2 CPU percentage, and also for the RAM percentage, and for the dashboard load time, which is less than 3 seconds. For the database design, it will design for the matrix hyper table to restore all raw matrices reading columns, include ID primary key, time as a partition key with the UTC timestamp. It will host name host name for monitor server matrix name, such as a CPU percent, which is a type of library. And for the alert hyper table, so stores only the there to hold breach event Columns include ID as a primary key. Okay, this for the ID column, and a time partition key with the UTC timestamp, host name, monitor servers, metric name for the alert, an actual metric value, a configured third whole value, severity warning or critical, and human readable alert messages. Okay, for the REST API, so all endpoints require an hashing function, API key, to do the authorization. So missing or invalid keys receive HTTP 401 unauthorized. So the methods is post metrics and post alert, get health, and get docs. Okay. This is the activity diagram showing what's happening actually in the system or in the agent itself. Like it's update every 30 seconds, collect the data, send the data, ensure the authorization to send the data, and so on. Send to the backend, visualize the API keys, and all of that. And there's some cases like if the HTTP 401 is unauthorized or what, it's also showed in the activity diagram. For the Grafana dashboard, look, this is a sample for the Grafana dashboard. I put it in here in the laptop, you can see. So it will show three statistical panels showing numbers of monitored servers, current highest severity level across all servers, green or for safe, orange for warning, red for critical. So this is the three categories we are using. Okay, so there is also for Grafana, it's also updated, like not just the agent that is updated every 30 seconds, but also the Grafana dashboard is updated. And it will have an alert history panel tab, historical trend rows. This is it for my presentation. So I have delivered the problem identification and background research, literal review of existing monitoring systems, and how each one is not suitable for STE, Similar Technology Enterprise. The technology stack, the RAD methodology defined, the system architecture design, database schema design, and Grafana dashboard layout design, functional and non-functional requirement documentation. This is it for my project. Thank you.